Our first lesson this year is on Pythagoras' theorem. We're going to start at the basics, which is called squares and square roots. And I don't know why it says patterns and division there, but you can ignore that. It's supposed to say square and square roots. In this lesson, I want you to learn about the area of a square and what are called square numbers. Now, before we can begin that, we have to make sure we clear up any confusion on what a square is and what a rectangle is. A rectangle is a polygon which has two sets of parallel lines and four 90-degree angles. So if you were going to draw a rectangle, you would draw something like this. This is what we normally would class as a rectangle. Now, it says it has two sets of parallel lines. So there's one here. Oops, just get back to this. One here and one here. There's also another set of parallel lines here and here. You'll notice that one of them has got two embedded arrows, a little bit off because my markboard's not quite aligned yet, and two single ones. This is a single embedded arrow, that's a double. What this means is that this side here is parallel to this side here. Remember that parallel means that they will, if you extend them in either direction, they will never cross. The double embedded arrows here and here means that this side and this side are parallel. Now it also says there's four 90-degree angles. If you look here, there's one here, there's one here, there's one here, and there's one here. This is the definition of a rectangle. Four 90-degree angles and two sets of parallel lines. Now a square is also a rectangle, but it's kind of a special rectangle. In a square, we still have the four 90-degree angles, but whereas in the beginning, at the first one here, you saw this side here and this side here being different lengths. In a square, this length and this length are the same. That's why it's special. You'll also notice we still have our parallel sides, so that this side and this side are parallel, that side and that side are parallel, and we have our four 90-degree angles. So we still fulfill the rules for a rectangle, but it's just special because it actually has equal sides. Now, all figures, when we talk about two-dimensional figures on a plane, have an area, and this area is measured in squares. So if I want to find the area of large rectangles, large triangles, or any size triangle or rectangle or circle or parallelogram, I have to measure it in square units. Now we measure in squares, which are the size of a millimeter by a millimeter, or centimeters, meters, inches, kilometers, miles, yards. Any type of a unit can be used to measure area. So the first one we're going to work with is centimeters because it's the smallest one, and it's actually easy to work with because we can get a ruler and make it work. So if you take a look at this here, I've got a square. Now that square is 1 centimeter by 1 centimeter. If you remember the formula before for a rectangle, it's length times width. So if I want to find the area of this rectangle, it's basically 1 times 1. That is 1 centimeter squared. So we know that this is a 1 centimeter squared. Now if I wanted to measure an area, what I do is I find out how many of these 1 centimeter squares will fit inside this this figure here. So you can see that I've got a rectangle here, which is here, 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 and here. And if I take the 1 centimeter square here and I put them down in here, you'll notice I've got 4 of them. So we know that a single square, I got ahead of myself here. A single square has an edge length of 1 centimeter and an area of 1 centimeter squared. Sorry, I forgot about that. Now, using that down here, 2 squares per side arranged in a square like this, 2 by 2, would have an edge length of, well, you can measure it right here, 2 centimeters, and has an area, well, you can count them here, 1, 2, 3, 4. So we've got 4 centimeter squares. So that's this rectangle right here that we have. If I had to take and measure it, does not want to do well for me today. Come on, there. There we go. So if I wanted to find the measurement of this right here, this square, I would have to take the 1 centimeter squares, put them in there, and find out how many fill it. And you can see we have 4 of them. So this square right here has an area of 4 centimeter squares. Let's go on to a larger one. You notice that now we've got 3 squares per side arranged in a square. So we have an edge length here of 3 centimeters. And an area of 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 centimeters squared. Now, as we get into larger and larger squares, you don't have to count them. We know that this is a rectangle. The area of a rectangle is length times width. In most cases around, when we're working with squares, it's called a side by a side. So you probably see formulas like for area of a square of this. Take the side and you square it, or you multiply it by itself. So you can area is equal to side times side. You could use area is equal to length times width. That works too. So going on to the next one, here's one that's got 4 by 4. So the 4 squares are arranged, the 4 tiny squares are arranged on the sides to make basically a 4 centimeter length on the side length. There's your 4 right there. 1, 2, 3, 4. And it makes an area of 16 centimeters squared. And you can count them all and figure out that there's 16 of them. Now, you'll notice that these ones I've done, 1, 4, 9, and 16, all have whole numbers. Okay, this is what we do this because it forms a special kind of a square, and that's called a perfect square. Okay, so this is referred to as a perfect square. I can't get it on there. Okay, and because it's called a perfect square because it has whole numbers for each side. Now remember, whole numbers are 1, 2, 3, 4, 5, 6, 7, no decimals. So if you go back here and just do a quick review here, you'll notice that whole numbers, right? No decimals here. That's 2 by 2, right? This one is 1 by 1. This one is 3 by 3. This one is 4 by 4. You'll notice there's no decimals. It's not 1.2. It's not 1 and 7/8. There's no fractions. It's all whole numbers. Okay? So if you know the area of a square, the question is, how can you tell if it's a perfect square? Well, to do this, what you have to do is search through your knowledge and find out, is there a whole number that multiplies to give you this area? So you want to find the whole number that multiplies by itself to give this area. So a question would be something like this. Here's a square on a question. It's going to say this is 16 centimeters squared. And it's going to ask you, is this a perfect square? Well, what you have to find is, what length are these 2 sides? Remember, it's length times width. So is there a number here and here, which is the same number because it is a square, that will multiply to give you 16? So what times what equals 16? Well, we know it's 4 by 4. So we know that this is a perfect square. Now, just as a quick other example, what if this one was not 16? What if this one was 10? All right. Well, if it's 10, what times what gives you 10? Well, we know that the factors of 10 are 1 and 10, 1 times 10. 2 and 5, 2 times 5. Those are the only whole number factors that we know about. There are no numbers that you can multiply by itself to get 10. 3 times 3 is 9. 4 times 4 is 16. So those are the only whole numbers. So this one here would not be a perfect square. Okay, so let's do a couple of examples here. Which of the following are perfect squares? 25, 18, 49, 30, or 100? Well, there's a couple of ways you can approach this. The first one is to try and list the perfect squares. And those are, these are the perfect squares. 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, etc. So taking a look at these are the first 7, or 7, 8, 1, 2, 3, 4. These are the first 8 perfect squares. Any area in between these numbers, so a 5, would not be a perfect square. So it's 25 in this list right here. 25 is a perfect square because 5 times 5 is 25. 18 is 18 in this list. You'll see the 18 will be somewhere in here. It's not 16, it's not 25, so this is no. There are no numbers that multiply by itself to give you 18. What about 49? Well, that's 7 times 7. So this one is a yes. I suppose I should put yes here because that answers the question. What about 30? Well, you'll see 25 and 36. 30 is between them, so it doesn't work, so this is a no. And finally, 100. Well, a 100 is 10 by 10. So that means that this is 100, so this is a yes. So if I asked you to tell me if a square is perfect, and I give you a drawing, like 10 or 24 or 25 or 30 in a situation like this, or even if I just gave you the number and told you that the area was 25 or 18, if I asked you whether this is a perfect square, you have to do this. Find out if there's a number which multiplies by itself to give you the number I've given you. If you can, it's a perfect square. If you can't, it's not a perfect square, like 18 here. So one of the most common questions is, draw a diagram to show that 25 is a perfect square. If you want to prove that something's a perfect square, it's really simple. All you have to do is draw that square. If this area is 25, this is 5 by 5. Because you've shown that these are whole numbers, you have proven that 25 is is a perfect square. Because 5 times 5 is 25. So that's all you have to do when you get that question. You might want to remember that. I do it quite often. All right, so now let's go backwards. What if I told you that the area inside a square is 36? And that's meters squared. And I want you to tell me what is the side length. And remember, this is a square, so that means that those two numbers must be the same number. So if you go back through the list we had here a second ago, you'll see that 36 is listed here, isn't it? This was 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. This one is 6 times 6. So this is 6 meters by 6 meters. So you have to know your times tables. It's helpful. Now in a minute I'm going to show you how to use your calculator to do it. Okay? And what is the area of a square that has a side length of 12 meters? So now you notice that I'm asking what is the area here. This is what is the side length. You have to read carefully. Okay? So I want to know what is the area of a square if this is 12 by 12 and we're in meters. So in order to find this area, we know it's the two side lengths multiplied by itself. So area is 12 times 12, which is 144 meters squared. So how did I find that solution? Well, what you need to do is to know your times tables. If you don't know your times tables, it's going to be difficult for you. There are other options, obviously, and that is using your calculator. But if you use your calculator, you're going to put down the answer, how did you find the solution? I used my calculator, and I'm not going to accept that. You have to give me more than that. So what did you do here? I found a number. Sorry. Got this backwards. I was thinking of square roots. Okay. I took the side length and multiplied it by itself. get the given area. Okay? Now, show that 11 is not a perfect square. This is a little more trickier. So what I'm going to do is we're going to pull up our calculator from last year. Now, I need to know the area here is 11. That's in here. I want to know if this and this are whole numbers. Remember, perfect squares have whole numbers in them. So let's take a look. What times what gives you 11? Well, I know that 3 times 3 is 9. And I know that 4 times 4 is 16, but 11 is between them. So how am I going to prove this? Well, you're going to get your calculator out, and you're going to find what's called the square root of 11. Now, the square root of 11 is using what's called the radical sign. This is the radical sign right here on the end. It looks like this here. On some calculators, like that on some calculators, like that on some calculators. It gets kind of, different depending on your manufacturer. But it's called the radical sign, and this is what you're looking for, right there. Okay? Now, depending on your calculator, it will put a square root like this, or it'll put the radical sign like this, waiting for it to happen. So, clearing this off so that I can work with this. I want to find the square root of 11. Okay, this calculator is different, so I have to put the 11 in first and then hit square root. So what this is saying is the square root of 11 is 3.3166247903554. Okay, if I go to the scientific view, you'll see that the square root of 11 has even got more numbers in it. Okay, it doesn't end and it doesn't repeat. So how am I going to use this to show that 11 is not a perfect square? Well, in order to be a perfect square, this number here, this 3.3166, should be a whole number, and it's not. So all you've got to do is put 3.31 here, and I guess I should round it correctly, to 3.32. That's telling me that this is roughly 3.32. It's not a whole number, so therefore, it's not a perfect square. All right, let's go back over another example. I'm just going to add a page here. We're going to take a number. Is 12 a perfect square? So what you'll do is this is what you want to find. So to do that, we need to find whether or not there's a number that multiplies by itself to give you 12. 3 times 3 is 9. 4 times 4 is 16. So we know the solution, the square side length, is going to be between 9 and 16. So pull your calculator up. Here's my calculator on this thing. I guess it disappears when you don't use it. Give me a second to pull up. Okay. Well, let's make this a little bit easier to work with. I'm going to go with a standard view. So I need to know the square root of 12. So here is the square root of 12. Oh, this silly thing again. Oh, wrong button. The square root of 12. 3.4641. So to prove that this is not a square root, not a perfect square, all you have to do is write down 3.46 and 3.46. That is the proof that 12 is not a perfect square. Okay? All right. Let's go down to a problem here. Bob wants to make a border around a square picture. So he's taken a photograph, and he has a square photograph. And what he wants to do is hang it on the wall, and he needs to put a border around the outside. We want to know what is the length of the border he needs to go around the outside of this picture. Okay? So if the picture has an area of 49, this is where it comes and becomes very helpful if you just draw a little bit of a picture here. There's 49, and our units are meters squared. So this is kind of a, I guess it's not a picture. It's huge, 49 meters. It'd be the size of, quite a big thing. I guess you drew it on the ground. I want to know what is the area, what is the length from here, to there, to there, and to there. All right. Now to do that, I need to know what this length is here, 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 and here. Since it's 49 and it's a square, I know that 7 times 7 is equal to 49. That means it's a perfect square. That lengths, these lengths here, must all be 7. So what's the perimeter of this, or what's the distance around the outside? It's basically 7 plus 7 plus 7 plus 7, which is 28 meters. Now you can change it and go 7 times 4, save yourself some work, but don't forget, you must include the proper units. Now this is meters when you're doing length, meters squared when you're doing area. Don't forget that. All right, what I'd like you to do is now complete your assignment. If you have any questions, please come talk to me. Otherwise, hopefully this was helpful for you.